Toyota helped start the electrification revolution in 1997 when it introduced the hybrid electric powertrain and proved its viability for use in passenger vehicles. Since then, Toyota has expanded its hybrid EV range to include multiple vehicles that have sold millions worldwide. Today, Toyota's latest hybrid EV system, also known as the Toyota Hybrid System, or THS, is an evolution of that original series parallel design, where the wheels can be driven by the gas engine or the electric motor, or both, and it's been further refined to provide better performance and efficiency. Above all, the hybrid EV THS system never needs to be plugged in, since it completely charges the hybrid EV battery via engine power or regenerative braking. Plus, its components, including the hybrid EV battery, have been designed with longevity, durability, and reliability in mind. As part of Toyota's Beyond Zero vision for a carbon-neutral future and more, the hybrid EV THS system helps make electrification accessible to all. By choosing one of Toyota's many low and zero-emissions vehicles, everyone can help drive even more electrified miles and help reduce carbon emissions. That's driving change towards a brighter tomorrow, and that's our Beyond Zero vision. With that said, to really appreciate how the powertrains in these vehicles help reduce carbon emissions, it's important to understand what's happening under the hood, learn how they operate, and take a closer look at the entire process from the moment the start button is pressed. Unlike a traditional gas-powered vehicle that cranks a starter motor to get things going, a hybrid EV start button first powers up the system's onboard computers, the electronic control units. Like virtually all automotive systems, these ECUs operate on the 12-volt battery circuit, which also powers vehicle lighting, windows, door locks, and similar features. This explains why you'll find a typical 12-volt automotive battery on every Toyota hybrid EV. Once online, these ECUs check things like the hybrid EV battery status, engine temperature, and ambient temperature. They also manage some of the most crucial components in the vehicle, the system main relays. These relays are next in line and do the heavy lifting of sending hybrid EV battery power to the components that utilize high voltage, and ensuring the battery power is switched on in a safe manner when the vehicle starts, to avoid spiking any element of the system. For safety, if any fault or collision is detected, these relays are designed to immediately power down, isolating the hybrid EV battery while shutting off the high voltage cables, which are color-coded in bright orange. Once the ECUs are up and running, the hybrid EV battery power is sent to the inverter converter. This device controls the high voltage flow to and from the motor generators and the high voltage battery, and maintains the charge on the 12-volt battery anytime the vehicle is running. The motor generators, as the name implies, works as both a motor, providing power when needed, or a generator to charge the hybrid EV battery. Each plays a critical role in how the hybrid EV system works. Motor Generator 1, or MG1, is located directly behind the engine, and when used as a motor, starts the engine on demand anytime it's needed. Because MG1 is much more powerful than a traditional starter motor, it doesn't require a gear drive and is able to start the engine silently. This is the reason you never hear the typical starter sound on a Toyota hybrid EV. Once the engine is running, MG1 is used as a generator and charges the hybrid EV battery. A major key to how the hybrid EV system works is a planetary gear set that acts as a power split device. This is used like a continuously variable transmission to manage the output between the engine and the motor generator 2. Parallel power output from the engine and MG2 work together, or separately, to power the wheels when accelerating and cruising. MG2 also acts as a generator when the brakes are applied or when coasting to capture the energy from the vehicle's forward momentum and charge the hybrid EV battery anytime the vehicle slows down. This two-motor hybrid EV design also takes advantage of Atkinson's cycle cam timing, which essentially means the intake valves stay open slightly longer and create less pressure in the cylinders. This design makes for exceptional efficiency and low tailpipe emissions. But the trade-off is a relative lack of power. That's why it works alongside Motor Generator 2 to produce a combined pool of power, helping provide both exceptional efficiency and good power response, the best of both worlds. So what if you want to make a front-wheel drive hybrid EV an all-wheel drive vehicle? It's surprisingly simple. Unlike traditional all-wheel drive vehicles that use a mechanical drive shaft to distribute the power from the engine out to all four wheels, Toyota engineers simply add an additional third motor generator directly to the rear, right in between the wheels. This explains why it's called Motor Generator Rear. This standalone unit has no mechanical connection to the rest of the drivetrain, but still helps add extra traction, capability, and power at the rear when it's needed. And like MG2, generates power for the hybrid EV battery when coasting or braking. The Toyota Prius pioneered electrified mobility when it was first introduced. And today, Toyota offers an electrified vehicle to fit every consumer, including plug-in hybrid electric vehicles, or PRIME vehicles. As part of Toyota's Beyond Zero vision for a carbon-neutral future and more, the PRIME plug-in hybrid EV helps make electrification accessible to all. By choosing one of Toyota's many low and zero-emissions vehicles, everyone can help drive even more electrified miles and help reduce carbon emissions. That's driving change towards a brighter tomorrow. And that's our Beyond Zero vision. In the previous video, we explored how the Toyota Hybrid EV System, or THS, works. Now let's find out how the PRIME plug-in hybrid EV powertrain functions, and how it's different from a hybrid EV and a battery electric vehicle. Toyota's PRIME vehicles are plug-in hybrid EVs that build upon the legendary THS architecture. They feature a similar layout with a gas engine up front coupled to two electric motors. Additionally, vehicles with electronic on-demand all-wheel drive add a third electric motor on the rear axle. PRIME plug-in hybrid EVs enhance the capabilities of the venerable Toyota Hybrid EV System, resulting in improved performance. Like the standard Toyota hybrid system, Motor Generator 1 works as a starter for the engine and recharges the battery when the engine is running. Motor Generator 2, on the other hand, recharges the battery when the vehicle is coasting or during braking. It powers the wheels on its own or alongside the gasoline engine in normal driving conditions. In PRIME plug-in hybrid EVs, Motor Generator 2 is also used for high-speed driving in all-electric mode. Finally, if equipped, PRIME plug-in hybrid EVs use Motor Generator Rear when driving in all-electric mode, resulting in additional traction and power during zero-emissions operation. Another major distinguishing factor in PRIME plug-in hybrid EVs is the battery, specifically its capacity. Vehicles powered by the Toyota Hybrid EV System already use a high-voltage battery pack to power their electric drive system. But PRIME plug-in hybrid EVs have an even higher capacity battery unit that allows for their extended EV mode driving. In fact, when charged up, PRIME plug-in hybrid EVs can drive for miles up to highway speeds on electric power alone, perfect for a zero-emissions daily commute. However, if the battery charge level gets low from either extended range driving or if the vehicle hasn't been plugged in, the PRIME plug-in hybrid EV powertrain continues to operate normally. The vehicle just automatically reverts to hybrid mode instead, with the gas engine coming online to support the electric drive system. This flexibility is the whole beauty of Toyota's PRIME plug-in hybrid EVs. They can offer the advanced convenience of all-electric driving for shorter trips and everyday commutes, or simply operate as fuel-efficient hybrids when that EV mode isn't available. Additionally, PRIME plug-in hybrid EVs aren't only about efficiency. With the added battery capacity and the electric motors working together with the gasoline engine, these are some of the quickest accelerating vehicles in the Toyota lineup. Like the Toyota Hybrid EV System, PRIME plug-in hybrid EVs use a high-voltage battery designed with longevity, durability, and reliability in mind. And, like a battery EV, they also include an onboard charger and a charging cable. This allows owners to simply plug the vehicle into a standard wall outlet to recharge, or a Level 2 240-volt charger for quicker charge times. The onboard charger converts the incoming AC electrical current to DC current, which is what the battery uses to store power and power the electric motors. This ability to plug in enables PRIME plug-in hybrid EVs to charge the battery beyond what a standard hybrid EV system would do through self-charging. That said, PRIME plug-in hybrid EVs will still self-charge the battery when needed. just at the level needed to maintain hybrid operation instead of all electric. That means the gas engine recharges the battery when needed, and the vehicle goes into all-electric operation during low-speed driving, traveling downhill, or coasting, just like how the Toyota hybrid EV system operates. So while there are certainly benefits to plugging a prime plug-in hybrid EV in, it isn't required, providing peace of mind if a charger is not available. It really combines the best of a battery EV and a hybrid EV, all in one cleverly engineered vehicle. So that's a quick look at the plug-in hybrid EV system inside Toyota's Prime vehicle.